Hi there, my name is Christopher Worst and welcome to the fourth video in the Homework 2 playlist for Material Energy Balance. This video is going over question 4, which is on the screen here, and it asks us to, using Cardano's formula, write a Python function to calculate the specific volumes for a given pressure and temperature for the SRK equation of state. So to do that, we're going to be using the Python scripts that we wrote in the previous question, question 3, as well as some values given underneath the values given that we used in the previous question that's on our OneNote. So for the cubic equation, we have Q, we have R, we have some determining characteristics. If R squared is less than Q cubed, then theta has a value, and then you can find x1, x2, and x3. There are some other values here with A, some roots, a different A, B, etc., etc. So let's begin. First thing we want to do is define is to create a function in order to find the cubic roots. So define cubic roots with given values of A, B, and C. So A, B, and C. So given those values of A, B, and C, we need to input Q and R. So Q is equal to, these are the two important values, A squared minus 3B divided by 9, so A squared minus 3 times B divided by 9. B is equal to, not B, R is equal to lower R. Yes. R is equal to 2A cubed, 2 times A cubed, minus 9 times A times B, plus 27 times C. So plus 27 times C, and that is all divided by 54. So enclose all this in parentheses, divided by 54. So we now have our Q and R values, and the rest of this is dependent on the values and the relationship between R and Q. So we're going to be doing an if-else value. So if, I believe it's R squared is less than Q cubed. Yes, if R squared is less than Q cubed, then oops, no then. There. So good. Okay. So then theta, we have a value for theta is the arc cosine that we're going to be using numpy for. So theta is equal to np dot arc cosine. Good. The arc cosine of r divided by q to the power of 3 halves. Yes, q cubed. Yes, q cubed. The square root of q cubed, so q to the power of 3 halves. That's good. And then the 3 roots, so we can now create a value for roots, called a variable of just roots, is equal to, and this is going to be an array. So 3 values, negative 2 q cosine. Notice how all of these have negative 2 times the square root of q in front of them. So we're going to put this outside of the array. So negative 2 times q to the power of 0.5. And I need to, instead of 3 halves, 1.5 there. Instead of 3 halves, 1.5 is used because division will still be used. Otherwise, that would need parentheses in order to make sure it was to the raised to the power of 3 halves. So that's easier instead. Now the difference is in this cosine. So we're going to be using times np dot cosine of, now we're going to be using our array, and the three values are theta divided by 3, so theta divided by 3, comma, to separate theta plus 2 times pi, so theta plus 2 times np dot pi divided by 3. One more separation for one last value, and then it's just theta minus 2 times np dot pi divided by 3. Yes. And then all of this is subtracted by a divided by 3. Yes. And I just want to make sure that this is indeed a. Yes, that is a, not alpha. So a divided by 3. Awesome. So we have all of our roots. So now we just want to return np.sort roots. So that is what we return, and np.sort will range it from greatest to least, or least or greatest, whatever you wish. And now we need an else. So if else. Now, if this case where r squared is less than q cubed is not true, then a is equal to negative parentheses r plus the square root, so r lowercase r plus the square root of, so r squared, and I believe that is minus q cubed, close parentheses to the power of 0.5 for the square root. And then all of this is to the power of 1/3. To the power of parentheses 1/3. Good. Now we have a. We also have down here b. We have made a mistake. We used the wrong equation. So we need to add a little bit here, just a few things. So we need to add negative np dot sine of r times, this needs to be an absolute value, np dot abs parentheses there. So yeah, so negative sine r just sine just brings back the sine of r. So if r is positive, then it will bring back a positive 1. If r is negative, it will bring back a negative 1. So sine doesn't do anything, it just takes the plus or minus out of r and inputs it there. Times the absolute value of r, we always want that to be positive, and just to make sure, square root, cubed, squared, 1/3, yes, nothing else has changed here. So, np times 1, 2, yes, all the parentheses look closed, we are set there. There. Now that we have that, b has multiple values, so b, we could write another, we're going to write another if statement, but it's a small statement, so we're only going to write it in one line. So b is equal to q divided by a if a is not equal to 0, else b is equal to 0. Done. And then, from there, input here. x1. So return a plus b, a plus b plus, or minus small a divided by 3. And I do believe this is giving me an error, so I'm going to do the other way around. If a equals 0, then b equals 0. Otherwise, b is equal to q divided by a. Let's just make sure that that is correct. Again, yes, q is divided by a plus b minus a divided by 3. Okay, well, first we should put parentheses a. There. Now we have that. We can shift enter. Can't assign to a conditional expression. It's odd. Maybe. Aha. Yes. So here. So instead of having a separate b is equal to, you need just, it takes this value if a is equal to 0, otherwise it is this value. There. Shift enter, now it works. Awesome, so we have our cubic roots. Let's output some cubic roots just for the sake of it. What should we output? R needs to be bigger, so let's do 1, 1, and 1. -1. Okay, so that is obviously not the right type of root, so try 2, 1, and 1. Still no. 3. There we go. So if we have correct values and values that allow it, we get roots. We got 3 roots sorted from largest to smallest. So -9, -2, 1. Of course, you have decimals there. So we know that it works now. Next up, we need a function that will use these cubic roots and some of the values that I have written in the down from yesterday. Here, yes, you can see that. Here to bring us our values here to find z, and remember, define cubic volume with givens. We need pressure, temperature, and pressure, temperature, should be just pressure and temperature. Actually, no, we just need, should just need temperature, actually, because we can input cubic pressure. Now that I think about it, we do need P. We do need pressure. Now we can input, so first thing we need is A, B, E, and S. So we need to unpack that from cubic function for those values, given value t. Next, we want to return, because remember, v is equal to, if I have my sheet of equations here, v is equal to z, so we need z times r times t, divided by pressure. So we have that. So that is our volume values. Now we need to find z. So, well, let's do cubic z is equal to cubic roots. We're using our cubic roots function for a, b, and c. So what is a? Well, a is the value that is equated to z squared, as shown. Where is it? Here. So a is the value equated to x squared. It'll be z squared. So we have that written down. So it is sigma. So s plus e times beta minus beta minus 1. Nope. 1. I want to enter because it makes things easier. So we've got the first value that we wrote down. So next up is for z, we have sigma, so s times e times beta squared minus s plus epsilon, so e, times, again, beta squared minus s plus e times beta minus q times beta. So now we have that one. That one's longer. And now we have c. So c is equal to negative, what is that? S times e times beta cubed minus s times e times beta squared minus q times beta squared. Awesome. I am going to get rid of these because they're unnecessary. Okay, that is much better. So we have z. We are missing two important unknowns here, so we need beta. Well, we already know beta. We used it up. No, actually, we didn't use it up here. We haven't used it yet, but we have been given the equation for it. So we know that. Where is it? Here we go. Beta is equal to b times. So beta is equal to b times pressure. So b times p divided by r times t, then I'm going to space those out. And we also know q, so q is equal to, here, a divided by b times r times t. Space those out. And we should have our z value, we should be able to return it, shift enter. And just to make sure that it works, cubic v, hello email. Let's do values of 1E7 and 600. Let's check to see it works. I don't think it worked. At least not as it's supposed to. I'm not 100% sure where I went wrong. It's potentially this, although I'd be surprised. Shift enter, try that. It might have been a non-float. No, it's not that. I don't think it's this. It could be the fact that I simply put too many parentheses around. Although it usually doesn't cause any issues. It's quite possible. Now, aha! I know where this is now. It is here. So this needs to be if r, because, again, I missed here, r. Is that the only issue? Okay. Try that again. Okay, that is much better. Try one. Try all ones. No. No. we can assume at the very least that this will hopefully work. So try this again, try this again. That's much better. Now we do have our values here. We have an array of 3, so we know that the value, the first value will be negative 9.758. The second value is negative 2.1, and the third value is 6.17. So this is looking for specific volumes given P and T for the SRK equation of state. We found it using these, and given extraneous values of 1E7 and 600, we have these values now. Thank you very much for watching. Hope you have a wonderful day.